Hello everyone, let's welcome back to Let's Crack J in English, the channel of Unacademy. Just let me check my voice first. Alright, so just a moment. Yeah, no, it seems right. Alright. Okay, so let me start with my introduction. I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and have been mentoring IIT-JEE aspirants for the last 11 years. So before we begin, let me tell you about the Unacademy's platform. So if you're preparing for IIT-JEE, you can have two types of subscriptions on Unacademy. One is Plus subscription and other is Iconic subscription. In Plus subscription, you get unlimited access on the platform. You can watch live sessions of all the educators who are teaching on Unacademy, and all the test series and quizzes will also be accessible to you, and all these courses are well structured. Okay, so this is unlimited access which you get on the platform once you are subscribed, once you have Plus subscription. All right, these are the subscription charges. You can subscribe for 12 months, 24 months, 6, 3 and 1 month also, and 12 and 24 months you can see per month average price is uh, very low, and you get 10% discount also using the code JEET1. So use this code and uh, you'll get instant 10% discount. Now this is Iconic subscription which you get in which you get all the benefits of Plus, and apart from that you get a personal coach who will guide you throughout your preparation for IIT-JEE. Now your test analysis will also be done in a personalized manner. Your study planner will be customized. Bi-weekly reviews will be given to you highlighting the progress. All right, so this is Iconic subscription. And these are the subscription charges. Now you can subscribe for 6 months also in Iconic subscription, which is of 38,000, and 12 months 65,000, and 2 years it is 1 lakh. And of course you'll get 10% discount in the all these subscriptions using the same code JEET1. Use that code and you'll get 10% discount. Now one more information about Unacademy's combat, which is on 6th of December. Okay, so this is the most competitive and gamified IIT-JEE battle. I mean, so you can win a lot of prizes and rewards. So just enroll for that on Academy's combat. Now there's an Academy's learning app which you get there's an Academy's learning app. Hello Senani. Hello Lucky, good afternoon. Is it not working? Let me just check. This is working, I think, huh? Wait a minute. All right, so If you have Unacademy's, if you can download this Unacademy's learning app from Play Store, and after downloading it, you can start special classes, and you can also use the same code JEET1 to get the access for free content. All right. Now let's begin the session. So we are going to continue straight lines today. One moment. Let me just check my voice once again. Why is this not working? All right, so today I was about to start distance form of a line. Dakshan. Yeah, let's start. So distance form of a line. This is very important form in a straight lines. Now suppose you have a point, say h comma k, in the Argand plane, in the Cartesian plane. So this is the point h comma k. All right. If I ask you to measure if I ask you a point which is r distance on the right side of h comma k, r distance horizontally, okay. So this point is going to be you will just add r to x coordinate of this point P, right? It is going to be h plus r comma k, right? If I ask you this distance is r, okay. So this point is a. This distance is rpa. If we ask you to find a point, coordinates of a point which is above this h comma k, above, okay, that means parallel to y-axis, r distance, okay. So this is r units. Then coordinates of this point B are going to be h comma k plus r, right? But if I ask you a point which is in this direction, I'll have to define this direction. And how would I define this direction? This is a line which is inclined at an angle of theta with positive direction of x-axis, okay. So this angle is given theta, and this distance is r. So what will be the coordinates of this new point Q? Now that is our question. So if this angle is theta, this angle will also be theta, right? So now we need to see that what is the horizontal increment in h comma k, I mean in point P, and what is the vertical increment, okay. So if you can see, then using this right angle triangle PQ, and say this point is A, you can take this point A, then this distance is now r cos theta, right? R cos theta. I'm just removing this r now, okay, and this r as well. We can take them r1 and r2, okay, just to keep them separate. So now you can see this distance is r cos theta, and this vertical distance is r sin theta, right? This is r sin theta. So if I ask you the coordinates of point Q, then coordinates of point Q are going to be h plus r cos theta, comma k plus r sin theta. All right. This is also called distance form of a line, but distance is measured from point P. Okay, so this point will be given on a line, or one fixed point will be given on a line, and inclination of the line, or maybe slope, because if you know slope, that means you know tan theta, and if you know tan theta, then you can find sin theta and cos theta. Then you can write any point on that line. Say this is the line L. Then you can find any point on that line which is at r unit distance from P. So distance should be measured from this fixed point which was given in the question, h comma k. Okay. If this point is in the opposite side, say here, okay, downwards you can say, so this is, let's say, q dash, and this distance is r, because at r distance there will be 2 points, one on the upper side you can see in this diagram, and the second one is on the lower side. So this side the point is going to be, this distance is same r, so this point is going to be h minus r cos theta. Okay, so that point was h plus r cos theta comma k plus r sin theta. Now this point is going to be h minus r cos theta comma k minus r sin theta. Is that okay, Lakshan? Got it? So this is the form which we are going to use today. We are going to use this form today. Distance form. All right. Let's do one example. Okay. A point find, okay, I'm giving you the question, find the coordinates of a point on the line x plus y is equal to 2, which is at a distance of 4 root 2 from 1 comma 1. So you can see that 1 comma 1 is lying on the same line, right? So 1 comma 1 is the point on the given line, and you need to find the coordinates of a point which is at a distance of 4 root 2 from this given point, okay, on that particular line only. So try this one, okay, try this example. At a distance, okay, I have written that at a distance of, at a distance of 4 root 2, okay, that means at a distance of 4 root 2. What is happening? This camera adjustment is very... Dakshin, where are you from? Are you in class 11th? 12th, okay. And where are you from? All right. Bangalore. All right. Not able to solve? All right. See this. I'll tell you. So in this question, this line was given. Actually, the slope of line is -1, right? So it's not necessary that you draw the correct diagram, exact diagram. You can draw a line in any direction, but if slope is negative, then line is like this, okay? So I'm just taking this as sketch. So slope is -1, line will look like this. So I'm just making similar diagram, but it's all right if you make line in any direction. So this point is given, okay? This point is 1, 1, which is on this line, all right? Say this point is P. Now I need a point on this line only, which is at a distance of 4 root 2 from this, right? So say this point is A on the upper side and B on the lower side, because there will be 2 points, okay, at a distance of 4 root 2. So this is your R. R is 4 root 2, okay? Now we are going to apply that formula H plus R cos theta, K plus R sin theta. So this point is going to be 1 plus R cos theta, okay? So this point is going to be H plus R cos theta, K plus R sin theta. In this case, you can see H is 1, K is 1. This point is H comma K, okay? This point is H comma K. Now, the important point is to find sin theta and cos theta. So if you write tan theta is equal to -1. And also, now you can write y -1. So that means theta is 135. So now you can write sin theta. Sin theta is going to be 1 by root 2. You can make that triangle also, perpendicular upon base. So perpendicular is 1, base is 1, hypotenuse is root 2. Okay, so you can write sin theta 1 by root 2 and cos theta will be -1 by root 2. Make sure whenever tan theta is negative, then sin theta will be positive and cos theta will be negative, because theta is in second quadrant. For straight lines, theta is between 0 to 180. So if theta is between 0 to 90, tan theta will be positive, sin theta will be positive and cos theta will be positive. But if theta is in 90 to 180, so tan theta will be negative and then sin theta will be positive, but cos theta will be negative, okay? So I hope I'm clear. So now you have got sin theta and cos theta. So let's put in this formula. So this point is going to be, point A is going to be 1 plus R means 4 root 2, okay, and 1 plus R cos theta. So cos theta is -1 by root 2, all right, comma, second point is going to be 1 plus R is 4 root 2, sin theta is 1 by root 2, all right. So this is another point. Now similarly, you can simplify this. So if after simplifying, it is actually root 2 will get cancelled. So it is 1 minus 4, 1 minus 4 is -3, all right. And root 2 again will get cancelled, 1 plus 4 is 5. So you can see x coordinate is decreasing. Why x coordinate is decreasing? Because we are going, this line is going towards left side, okay, but y coordinate is increasing. For point B, now what will be the point B? For point B, you need to write H minus R cos theta, comma, K minus R sin theta, okay. So the sign will change, okay. So sign will change between these two numbers which you have written here. So this sign, this plus is going to be minus now, and this plus is going to be minus now. So it was 1 minus 4 earlier, now it is going to be 1 plus 4, okay. So you can directly write that. And it was 1 plus 4, so now it is going to be 1 minus 4, okay. So this point is going to be 5 comma minus 3, all right. So one point is this, -3, 5, which is on the same line and at a distance of 4 root 2. and this is another point on the same line, x plus y is equal to 2 and at a distance of 4 root 2. So I hope I'm clear. Huh? Have you got it? Now have you got it? All right. I'll give you one more example. A straight line. Now try to solve it. A straight line is drawn through the point 2, 3 and is inclined at an angle 30 degree, all right, with the x-axis. Then find the coordinates of 2 point. Then find the coordinates of 2 points on the line only, on the line at a distance of 4 units from P. Now this is again a straightforward question. So let's see if you are able to apply the formula now. So try this one. Write in the comment box if you get the point. Okay, you didn't get? It's all right. Okay, so let's apply the formula again. This point is given 2, 3. This line is inclined at an angle of 30 degree. Okay, so this is the line which is inclined at an angle of 30 degree with positive direction of x-axis. All right, this angle is given 30 degree. Now you can see from this distance you need to find a point on this line which is at a distance of 4 units. So 4 units away. Okay, so one point will be here A, and say the other point is B. Okay, and say this point is P. So this point's coordinates I'm writing it directly. It is H, this is H. Okay, this is your H and this is your K. So H plus R cos theta. Now remember that formula. So 2 plus R. What is R? R is 4. So R and cos theta. Now in this case theta is given. Theta is 30 degree. Okay, it should be inclination of the line with positive direction of x-axis, which is given 30 degree. All right. So cos 30, comma 3 plus K plus R is 4 sine 30. Okay, so now just simplify it. So it is going to be 2 plus cos 30 is root 3 by 2. So it is going to be 2 root 3 and sine 30 is 1 by 2. So 4 by 2 is 2 and 3 plus 2 is 5. So this point will be 5. So this is point A now. All right. Now similarly we'll write point B. So point B is going to be H minus. So it is 2. Now simply put minus sign. So 2 minus 4 cos 30. Okay. Between these two numbers H and R cos theta, comma second is 3 minus 4 sine theta. Okay, so sine 30. So if you simplify it, it is going to be 2 minus 2 root 2. This is one point, and the other point is 3 minus 3 minus 2. So it is 1 actually. So finally you can write this point as 2 minus 2 root 2 comma 1. So now you have got both the points. So I hope it is clear now. So this was actually the straightforward application of this formula. Now I am going to give you some better questions where we can apply this formula and understand the main usage of it, the importance of this formula. All right. See, in some diagrams like triangles, rhombus, rectangles, when a few vertices are given and you need to find the remaining vertices, then this formula becomes a very good tool to find the coordinates. Very good. Hi Shubham, how are you? So now let's try that. If A 3, 2 and B 7, 4. All right, are two vertices of a triangle, are two vertices of an equilateral triangle. Triangle ABC. Okay, then find the possible vertices, possible coordinates of point C. So of course you can see, you can okay, do I need to repeat this one, Dakshan? What do you want me to repeat? This previous question? You did not listen. Okay. I mean this question, solution. Okay. So I was saying that this point was given P, this distance was given 4, and inclination theta was given 30 degree. Okay. Theta was given 30 degree. So we needed to find the coordinates of a point on this line which is at a distance of 4 unit. Okay. So we'll apply the same formula, H plus R cos theta. So you can see H is 2. This is your H. Okay. This point is your H and K is 3. So I have applied that formula, H plus R cos 30 degree. R is 4. Okay. R is 4. Are you understanding it now? This P point uh, from which distance is given, okay, that is h comma k. That point's coordinate of that point is h comma k. Okay, so this is your h comma k. Now this is your r. Okay, r is equal to 4. So after when you apply the formula, it is h plus r cos theta. So 2 plus 4 cos 30 degree and k plus r sin theta. So it is 3 plus r and sine this angle 30 degree. So 3 plus sine 30. Just put the values of cos 30 and sine 30. Okay, and you will get the coordinates of A. For coordinates of B, which is below this point P, for that coordinate you need to apply this formula h minus r cos theta and k minus r sin theta. Okay, so it is 2 minus 2 root 2 and 3 minus 2. Just put the minus sign here. Okay, this plus will become negative and this plus will become negative. Okay, so in that way you can apply this formula. Now I hope you got it now. All right, now let's see more application of this formula. So two vertices of an equilateral triangle are given, and we need to find the vertex of the third coordinates of the third vertex. All right, so let's try this one. Seven cos theta. No, actually, it's slightly different. I'll tell you how to do it. Just a moment. See how to do it. The first point is, do you know the slope of a line along which you are measuring the distance? That is the main point. So if I make the diagram like this, say this is the triangle ABC. Then we can write the slope of AB, right? Using the formula y2 minus y1 upon x2 minus x1, right? So we'll get the slope of AB. But do we know the slope of AC? No, we don't know, right? We don't know the slope of AC. But we can find the slope of AC, but better option is, I'll tell you what is the better option. This point is 7,4. See, first of all, we know AB. AB, what is AB? So side length is x1 minus x2 whole square. So under root of, let's find the side length of this triangle. So side length of this triangle is 4 square. So 16 plus 2 square, 4. So it is root 20. Root 20 is 2 root 5. Okay, so AB is 2 root 5. No, 60 degree, but 60 degree is not with x-axis. Okay, that angle is not with x-axis. You know, we need angle with x-axis. This angle is 60 degree, okay? But this line AC is not making 60 degree with x-axis, right? So that is the problem. Now see, I'll draw a line along which we can find the coordinates and whose slope we can find easily. Okay, let me also write one thing. First of all, slope of, what is the slope of AB line? Slope of AB line is y2 minus y1. So that is 4 minus 2. 4 minus 2 is 2 upon 7 minus 3 is 4. So it is 1 by 2. So slope of AB line is 1 by 2. We can write the slope of line which is perpendicular to AB. So I'm drawing a line which is perpendicular to AB, right? This. And also one more thing, we can write the slope of this line. Say this point is D, okay? So this point is, say, P. We can also write the coordinates of point P. P will be the midpoint because this is an equilateral triangle. So altitude, median, angle bisector, everything will be same. So this white line which I have drawn is actually altitude of this triangle, as median of this triangle, as well as angle bisector of this triangle. So we can write the coordinates of point P easily. Coordinates of point P, basically P is the midpoint of AB. So applying midpoint formula, P will be 7 plus 3 by 2. So it is 5, comma 2 plus 4 by 2. So 6 by 2 is 3. So we have got the coordinates of point P and we know the slope of P. Slope of this line, PC. So slope of this line is basically slope of PC line, okay? PC line is minus 1 upon slope of AB because these two lines are perpendicular lines, right? So it is going to be minus 2, all right? So slope of PC line is minus 2. Okay, that means we have got tan theta. If this angle is theta, then we have got tan theta. So tan theta is how much? Minus 2. Minus 2 upon 1 we will write. And once we know the tan theta, then we can write the sin theta and cos theta. So what is sin theta? Sin theta is basically, if this angle is theta, this is 2, this is 1, then this will be 4 plus 1, 5. So we can write sin theta is 2 upon root 5 and cos theta is minus. I have told you when tan theta is negative, then sin theta will be positive and cos theta will be negative. So minus 1 upon root 5. Now we have got sin theta and cos theta. Now one more thing is remaining. From P we need to move in this direction, right? So that means we need this distance. We have got sin theta, cos theta. The only thing which is required is now distance R. So this perpendicular distance of this triangle, okay? So in this triangle, this AC is known. This AC is basically, how much was this? 2 root 5. This distance was 2 root 5, okay? So you can see this triangle. You can see this triangle. This is a right angle triangle, right? It's a right angle triangle. This is 2 root 5. This angle is 60 degree, right? So if this is 60 degree, then this R is going to be 2 root 5 sine 60. Vertical projection, right? You know that. Hypotenuse is 2 root 5. This angle is given 60 degrees. So you can write perpendicular 2 root 5 sine 60. So sine 60 is root 3 by 2. So root 3 by 2, then it is going to be 2 into root 5. Okay, so root 15 basically it will be. 2 and 2 will get cancelled and root 5 into root 3 is root 15. So it is going to be root 15. Okay. I hope this point is clear. Okay. So we have got R. R is how much? Root 15. Now we can write the coordinates of point C. Two possibilities are there. One triangle will look like this and other triangle can be like this also. C can be downwards also, right? You can make an equilateral triangle here also, okay? So it's just that you need to find a point R distance above P and R distance below P. So again we'll apply the same formula, H plus R cos theta and K plus R sin theta. So this is 5 H, see this 5, this is your H, plus R cos theta, R is root 15 and you have got the cos theta is minus 1 by root 5, okay, comma, y coordinate is K is 3 plus R is root 15, okay, sin theta is 2 by root 5, alright. So you can simplify it as it is basically 5 minus root 3, okay, and comma 3 plus 2 root 3, okay. So these are the coordinates. This is one of the coordinate, and the coordinate which is on the other side, let's take this c dash. So this is just put the sign, just change the sign between these two numbers, okay. So change this sign, this will become negative now and this will become negative now. So it is now 5, I am directly writing the answer, 5 plus root 3 comma 3 minus 2 root 5, okay, 2 root 3 actually. So these are going to be the coordinates of vertices. All right. I hope you are understanding this. Okay. One more question, okay. That's slightly difficult, okay. A line through a line through A minus 5 comma minus 4 meets the line x plus 3y minus 2 is equal to 0, meets the lines, and 2x plus y plus 4 is equal to 0, and x minus y minus 5 is equal to 0 at B, C and D. All right. If 15 upon AB the whole square plus 10 upon AC the whole square is equal to 6 upon AD the whole square, then find the slope of the line. Slope of the line which was given, which was mentioned in the question beginning. Slope of this line. This is slightly difficult compared to the questions we are doing in the beginning. Let's see. I knew it, but it's all right. I'll explain it. I'll explain this one. Just wait for a moment. Okay. See these distances AB, AC and AD. All three distances which are given in this equation are measured from point A. Okay, measured from point A. All right. So now you can see. First, let's find out what we need to find. We need to find slope of the line. Okay. So let's take inclination of the line to be theta with x-axis. Okay. So let inclination of the required line of the line with x-axis is theta. All right, so that means we can use that distance form. Now this line, this is the first line which is given. Actually this is x plus 3y minus 2 is equal to 0, and this is our line which is inclined at an angle of theta, this one. It means this first line which was given, I'm calling this line L1, this line L2 and this line L3. Okay, and our line is L. So this line inclination, we need actually tan theta. Okay, so we'll focus, we have already taken theta, we'll try to make an equation in theta, tan theta, and okay, and tan theta is our target. To find tan theta is our target. Now let's take this point which was given in this question. A is on this line, so let's take this point A here. A is minus 5 comma minus 4. Okay, I'm writing a general point on this line at a distance r units from A. So any point P which is at a distance of r units from A, can be written as minus, coordinates of P will be minus 5 plus r cos theta comma minus 4 plus r sin theta. Okay, now if I solve this point with this line L1, okay, with L1, and the value of r which we get from this equation, see, if r varies, let me explain it like this. If r varies, then this point will vary, right? This point will vary. So we need to find this, see this line meets this L1 at B. Okay, so we need AB. Okay, so to find AB, we are going to put this point in this equation. Okay, and from that equation we'll get R. Okay, and that R will be basically AB. R is AB. Okay, because we are solving our line, this line which is written in distance form with L1. Okay, so the value of R which we get from that equation is basically the value of AB. Okay, so I'm going to put this equation, and let me put it, then I'll explain it again. Okay, so if I put this point in this equation, it is going to be minus 5 plus r cos theta plus 3 times of minus 4 plus r sin theta. Okay, minus 2 is equal to 0. Sir, how you put the points on the coordinates of our, then what is the relation between them? See, actually this is basically equation of the line. X is equal to minus 5 plus r cos theta comma y is equal to minus 4 plus r sin theta. Okay, so this is basically the equation of line L. This is equation of line L written in distance form, and that distance is measured from point P. Okay, you can see L1 is given in general form, ax plus by plus c, and the equation of line L which we have assumed is written in distance form. Now we are solving these two equations, so when we solve it, we will get a value of r. Let's see, I have put this x and y in this equation L1. all right, and after putting it we are going to get r. So r is going to be r into cos theta plus 3 sin theta, and this is equal to, let's separate the numbers, it is minus 12 minus 5, so it is minus 50 minus 12 minus 5 and minus 12 minus 5 minus 12 and minus 5. Let me just check the equation. I think it was x plus 3y, it should be plus 2, I think. Wait a moment. X plus 3y minus 2, x plus 3y, so minus 5. Yeah, this is plus 2 actually. This is plus 2. So if I make it plus 2, then this number is going to be minus 5 and minus 5 and minus 12 and plus 2. So it is going to be 15. Okay, 15. And then r is going to be 15 upon cos theta plus 3 sin theta. Now what is this r? This is our main question. Okay. See, because we are solving line number L1 and this line, L1 and L, so R we get is nothing but distance of A from, it will, see, this R will represent the point of intersection of these two lines, right? R will represent the distance of point of intersection from A, this distance. So the R we have got is basically the distance of point of intersection from A. Because we have solved two equations. When we solve two equations, what we get? We get the point of intersection, no? We are not equating it to line L2. We are putting the coordinates of line L in L1. In that way, we will get the value of R, and that will represent distance AB. See what happens. Let me explain it like this. See, this is a line, okay? This is a line which is, if this coordinate is h comma k and inclination of the line is theta, okay? Then distance form is distance form which I was teaching is actually equation of this line written in distance form, and equation is x is equal to h plus r cos theta and y is equal to k plus r sin theta, okay? Now what is this r in this equation? R is basically, R is distance of this x comma y from this h comma k, okay? This. So as r changes, this point will move, this point x, y will move. If r is 2, point will be here. If r is 3, point will be here. If r is 4, point will be here, right? If r is 6, point will be here, x comma y. So if we change r, this point will move on this line. Are you understanding this thing? Now what happens? Suppose there's a curve, okay? There's a curve and this line, the line L, which line L meets this curve at certain point A, and we need this distance PA, okay? PA. So whenever you need a distance of a certain point on a line from a curve, then you write equation of the line in distance form, and distance is measured from that point from where we need distance, okay? And after that, we put this coordinate in the equation of this line and we get 1r. That r is basically corresponding to this point. Corresponding to this point means it will represent distance of A from P. Distance of A from P. I hope I'm making some sense. Thank you, Amit. Dakshan, are you understanding? Are you understanding? So this is what we are doing actually. We are solving the distance form of the line with this given line to get AB. Okay, so this R is nothing but this is basically AB. Okay, so we have got AB. Similarly, if I solve this same equation which is written here, equation number 2 with L2 line, second line, then we will get AC. Okay. Yeah, so now I am solving it with the L2. Okay, so L2 line mein, let's put the coordinates of this line L in L2. So it is 2 into x is minus 5 plus r cos theta plus y means minus 4 plus r sin theta plus 4 is equal to 0. So now because we are solving our line L with L2, so their point of intersection, which was C, okay, we'll get the value of R, and that R will be corresponding to point C. Point C means it will represent distance of C from A. That means AC we will get, okay, AC. So now let's separate R again. So if I separate it, it is minus 10 and minus 14 and plus 10 we'll get. So R times of 2 cos theta plus sin theta is equal to 10, and again we'll get R. As I told you, this R is nothing but AC. Okay, so we have got AC is equal to 10 upon this R is equal to AC is equal to 10 upon 2 cos theta plus sin theta. Now one more thing is remaining, AD is remaining. So how would you get AD? Dakshan, can you tell me how would you get AD? If you're understanding it, try to answer it. How would you get AD? See, these were the lines. This is line L1, this is line L2, this is line L3. Okay, so I have solved L with L1, then I have solved L with L2, and then I got AC. Okay, then I am solving L, this line L, all right, with L3. Okay, so if I solve L with L3, I'll get AD. All right, AD. So that means to get AD, you need to put these coordinates, I mean this x and y, in equation number 3. All right, in equation number 3. So if I put it here, let's get it. This is what? Minus 5 in this equation. Okay, L3 in this equation we are going to put. So it is minus 5 plus r cos theta. This is x coordinate minus y coordinate. Y coordinate is minus 4 plus r sin theta minus 5 is equal to 0. Okay, so now again try to separate. So this is going to be minus 10 and plus 4, so 6. 6, yeah. So it is r times of cos theta minus sin theta is equal to 6. All right, and we'll get r is equal to 6 upon I can't. 6 upon cos theta minus sin theta. All right, so we have got all three distances. This is nothing but AD. Okay, so now we have got AC, AD, and now we are going to put these distances in this equation, and we'll get an equation in sin theta and cos theta only, and from there we are going to get so I'm writing these distances in next page. So what was AB? AB is this. See, this is AB. This is your AB. This is your AC. All right. And this is your AD. All right. This is your AD. So I marked all three distances. Now let's put it. AB is 15 upon cos plus 3 sin. 15 upon what was that? Cos plus 3 sin. Cos theta plus 3 sine theta. Then AC is what? AC is 10 upon 2 cos theta plus sine theta. 10 upon 2 cos theta plus sine theta. And what was AD? AD is, let's find AD. AD is 6 upon cos theta minus sine theta. 6 upon cos theta minus sine theta. Alright. Now, what was the relation given? Relation was 15 upon AB square plus 10 upon AC square. So this was the relation given, 15 upon AB square plus 10 upon AC square is equal to 6 upon AD square. Alright. So let's put these values in this equation and we are going to get the answer then. I mean, we'll get an equation in sine theta. I was telling you this is a difficult question. Okay. Hi Vinkant, how are you? So let's put 15. 15 upon cos theta plus sine theta. 15 and 15 will get cancelled. It is cos theta plus 3 sine theta, the whole square. I'm directly simplifying it also. 15 and 15 will get cancelled. You can see that, okay? In this 10 and 10 will get cancelled and 2 cos theta plus sine theta will come up, right? So 2 cos theta plus sine theta, the whole square is equal to, now 6 will get cancelled and you'll get cos theta minus sine theta, the whole square, right? Open it, so you'll get cos square theta plus 9 sine square theta plus 6 sine theta cos theta. Now it's simple. Main part has already been done. Cos square theta plus sine square theta plus 4 sine theta cos theta. Alright. And this is now cos square theta plus sine square theta minus sine theta cos theta. Alright. So sine square plus cos square. See how many sine square cos square you have. So you have cos square plus cos square, 5 cos square, right? And 9 plus 1, 10 sine square. So 5 cos square plus 5 sine square will become 5 and 5 sine square will be remaining, right? So 5 sine square I am writing separately, 5 sine square will be remaining. And then 6 sine theta cos theta, 4 sine theta cos theta is 10 sine theta cos theta, and then plus this sine theta cos theta. So overall it is going to be 11 sine theta cos theta, okay? Sine theta cos theta. And right hand side, it was sine square plus cos square, so that will become 1. So this is the equation we are getting now. So it is 5 sine square theta plus 11 sine theta cos theta plus now 4 is equal to 0, right? And after dividing, sir, is resonance rank booster book enough for JEE Advanced? That's a good book, but enough you won't say. That's a revision package basically. Once you have done theory part and everything, okay, so you can do your revision with that. Anything can be enough and anything cannot be enough. That depends on your conceptual clarity. But it has good questions. It has very good questions, so you can solve it for better conceptual clarity and better practice. Yeah, minus sine cos we have taken to left hand side. Minus sine and cos we have already taken to left hand side, and you can see this 11. That's why we have got 11. Now you can divide it by sine square, cos square. If you divide the whole equation by cos square, it is going to be 5 tan square theta. 5 tan square theta. Alright. Let me check whether it was sine plus cos or sine minus cos. Oh, sorry. It was all right. So, okay, what am I doing? 5 tan square theta plus 11 sine theta cos theta. Oh, sorry, it will become, because we are dividing by cos square, so it will also become tan theta now. So this is tan theta, and plus 4 is equal to 0. All right. So 5 tan square plus 5 tan square plus 11. Okay. Okay. So we need 20. Okay, we need 20. I think it should be, there's some, maybe some error is there. Let me check the calculation. Let me check the answer first. What is the answer? We are getting everything. Yeah, everything is right. This was actually 2 sine theta cos theta, okay? Because sine theta 2 was missing. Cos theta minus sine theta whole square is sine square plus cos square minus 2 sine square cos square. Okay, so this will be 12 now. Instead of 11, it is 12 actually. So this will be 12 and this is also 12. Okay, that was the change. That was the change in this. It is 12. Okay, so now split it. So 10 into, you can split it in 10 into. So this 5 tan square theta plus 10 into tan theta plus 2 tan theta plus 4 is equal to 0. And from this we'll get actually 2 tan theta plus 1. One value will be 2 tan theta. Yeah, tan theta plus 2 actually. Let me write the factors correctly. So it is 5 tan theta. If you take common, it is 5 tan theta plus 2. This is one of the value, and other is tan theta plus 2. So we get tan theta is equal to minus 2 and tan theta is equal to minus 2 by all right. I hope I have done the calculation correctly. Anyway, so this was the solution. Yes. There might be some calculation error. I'm just unable to check it. So, all right. So this was the distance form. I'll finish it here today. Okay. You just check the calculation in the end later. I'm not sure about this calculation. This was the equation. Up to here it was correct. All right. After that you open it again and check the calculation. All right. All right. So I'll see you tomorrow. Tomorrow we'll continue with straight lines again. Thank you for joining. Yes, Dakshan, I will be teaching daily. The straight line is going on. You can watch previous sessions also, and it will be in continuation. Okay. 3 to 4. All right. Okay, then take care. All right. Thank you very much. Okay, Vinkant, Dakshan, Shubham.